Alright, time to talk about graphs of rational functions. So, before we get started with any graphs of rational functions, we're going to talk about a couple of things. First of all, a hole. A hole is a point where a graph is undefined. Now that happens when terms cancel, like in our last video. I called them a hole and I said we'd work with them later. Another thing is an asymptote. Asymptotes are lines that graphs approach but cannot touch. Now, I will tell you that that is true all the time for vertical asymptotes, but in rare circumstances it is allowed to be broken for a horizontal asymptote, and that because horizontal asymptotes that must follow it for the end behavior, sometimes the middle is allowed to break it. So, when you look at like a chart in your graphing calculator, sometimes errors can occur. Now, an error occurs in your graphing calculator when one of two things happens. And I can give you an example. So this -1 giving you an error could be an example of a hole. So if you had something like x plus 1 and x plus 2 all over x plus 1, in our last video we talked about those canceling and that being a hole. That's an example of how your chart could give you an error. Now another example of an error could be your vertical asymptote. So if we had something that looked like 2 over x minus 5, we know x is not allowed to be 5 in a denominator, so that would be another reason for you to have an error in your graphing calculator, which is pretty nice because it'll help you identify when something crazy is going to happen. So, let's get working. For each function, you're going to have to do a lot of stuff. So the first thing you're going to have to do is list any vertical asymptotes. So how do you list a vertical asymptote? The vertical asymptote is what makes a denominator 0, but when we're talking about graphs this way, this is not like domain. We need to simplify first. So the very first thing you need to do in any one of these examples, it doesn't even need to tell you, is you must simplify it. So this we can factor out a -3 on the top, leaving us with an x squared minus 1, which of course we can simplify even further to a -3, an x plus 1, and an x minus 1. And now on the bottom, we can just factor by what multiplies to 2 and adds to a -3, and we're just going to skip all the way to the end and call that x minus 2. And x minus 1 because that's just a one-step factoring problem. And we see that we have x minus 1s that cancel. So our final simplified answer is -3 times x plus 1 all over x minus 2. So, of course, I'm not going to make you graph these by hand. You will be allowed to use your graphing calculator to graph once we get to part E. So, once we have our simplified equation, part A, the vertical asymptote is what makes your denominator 0 in your simplified equation. So, in this case, we just set the denominator equal to 0, and we would say x is equal to 2. And it is a line. Remember, it is a line for an asymptote, so we need the x equals because it's a vertical line. Okay? Part B is write the equation in any horizontal asymptotes. So horizontal asymptotes can happen 3 ways. It can happen if you have more x's on top, you have no horizontal asymptote. If you have the same number of x's on top and bottom, then the horizontal asymptote is the ratio of your leading coefficients of the top and bottom. And finally, if you have more x's on the bottom, it's always going to be y equals 0. So let's go look at our simplified equation again. We have 1x on top. We have 1x on the bottom. So this is going to follow the middle. Same x's on top and bottom. It's the ratio. So we have a -3 over a +1. So we have y equals -3. Remember, this is a line. This is a horizontal line for your horizontal asymptote. So that takes care of part B. Now we need to list the coordinates of any holes. Now to list the coordinates of any holes, there's a little bit of work involved here. And that's because we have to take what canceled. So our hole is at x minus 1. So we're going to take our x minus 1 and set it equal to 0 and find out that x is equal to 1. Now that is just the x coordinate of your hole. Now you have to go find the value of it, and you do that by substituting it into your simplified equation. So we have a negative 3 times 1 plus 1 all over 1 minus 2. So 1 plus 1 is 2 times a negative 3 is a negative 6 over 1 minus 2 is a negative 1. So the answer is 6. So our hole is at 1 comma 6. And finally, we're going to state the domain and range. The domain and range is stated like we stated it the other day, except for now we have to state the range as well. So your domain is x, and x can be anything except for any x coordinates of holes. So x cannot equal 1. And x cannot equal your vertical asymptotes. So your domain is anything except for the x in part C and the x in part A. Now your range is y. Y can be anything except for any y coordinates of holes, in this case 6, and any horizontal asymptotes, which in this case is y is equal to a negative 3. So that is your domain and range. Okay, now for the graph, part E. As I mentioned, you are totally allowed to use your graphing calculator to do this. So you would just type your simplified answer into the Y1 of your calculator, and you'd press graph. However, you're going to be able to do a few things without. So we have an x equals 2. You must graph your vertical asymptote. So you're going to sketch it, and you're going to call it x equals 2. Okay, you just need to sketch. You need to sketch your horizontal asymptote, which is y is equal to a negative 3. So we have a horizontal line at y equals negative 3, and we call it negative 3. And then, of course, you have your hole, which is at 1 comma 6. So we're just going to put a hole right here, and we can call him 1 comma 6. And then the graph itself, you can just type in the graphing calculator again, and it'll look a little bit like this. We just need a nice little sketch of it. You do not draw your line through the hole. You do not cross your or your asymptotes of any kind. And that's it. So your graphing calculator does the graph for you, but you are able to graph the horizontal and vertical asymptotes without the use of your graphing calculator, because it doesn't even do it. It doesn't even graph your hole, so that part's on you. Okay? So that's it. That's how you graph these crazy rational functions. So we're moving on to another example. The nice thing about this example is it's already factored for you. So I would like you to practice doing everything else. I want you to list your vertical asymptotes, your horizontal asymptotes, your holes, your domain, your range. Take your graphing calculator and graph it, and I will warn you now, something funny is going to happen, and again, I will remind you of why it happened that way. Okay? So get going. Try this on your own. Pause the video, and I'll be back in a few. So that probably took you a little while because there was quite a bit of information to list. So here again, we had 2 cancellations, so we have 2 holes. Our final simplified answer has an x plus 1 and an x plus 5, so our vertical asymptotes are x is equal to a negative 1 and negative 5, graphed over here. We have, now if you were to imagine that this was being FOILed out, we'd have a 3x squared and an x squared for our leading coefficients. So that same number of x's on top and bottom, we have x squared and x squared. So that simplifies to 3 over 1. So we have a y equals 3, which is graphed. We have 2 holes at 2 and 4. When you plug them back in, I don't really care if you give me the fraction or the appropriately rounded decimal. The domain is x cannot equal anything in part A or the x coordinates of part C, also known as your vertical asymptotes, and x coordinates of holes. So we have all 4 of those. But why is my range all reals? And that's because that weird thing happened that I told you can happen from time to time. Is if you have a middle section, Horizontal asymptotes only need to be followed for the end behavior. So see how it's following it out here as you go to the right and as you go to the left. The middle can be broken. Vertical asymptotes will never be broken, but these in the middle can be broken. So since the graph starts high, goes low, no restrictions, it gets rid of that y cannot equal 3 and y cannot equal the 5/3 and the 91/45 because this middle section takes care of that for you. Okay? So that one's a little tricky, and of course you have your sketch that you could have used your graphing calculator. Just make sure you label your stuff appropriately. So the last three examples here are just extra practice with vertical, horizontal, and holes. So what I would like to do is go through number 3 with you really quick. Of course, it needs to be factored first. So we have x plus 5 and x minus 5 when you factor the top. And when you factor the bottom, you're going to have an x plus 5 and you're going to have a 4x minus 3. So as we see, that's going to cancel and you are left with an x minus 5 over 4x minus 3. So from there, our vertical asymptote is in the simplified. So vertical is x is equal to 3/4. The horizontal is we have same number of x's on top and bottom, and there's an imaginary 1 here, so this is y is equal to 1/4. And our hole is what's been canceled, so we have a -5 for the x coordinate, and you substitute a -5 into here, and you're going to get 10/23, or the decimal value of 0.435. So that's number 3. It's just practice with vertical, horizontal, and holes. So you've guessed it, you get to do number 4 and 5 on your own, and then we're done. Pause the video and give them a try. And let's see if you got them right. So number 4, you had to just cancel this one set of terms here. And your vertical asymptotes are x equals 1/2 and a -7, because that's what makes the denominator 0. The horizontal asymptote is y equals 0 because you have more x's on the bottom. If you were to imagine this being FOILed out, you have 2x on top and you have 2x squared on the bottom. So you have more x's on the bottom. That means horizontal asymptote of y equals 0. Your hole, this is going to give you a -2/3. Plug it back in and you get a crazy fraction, or 0.023. Number 5, you simplify the bottom only. Nothing cancels out and you have more x's on top. And that's going to give you a vertical asymptote of a -1 and a +1 from the denominator. Since you have more x's on top with x cubed on top, again, if we were to imagine foiling out the bottom, we have x cubed on top, so there's more on top, which means no horizontal asymptote. Nothing canceled, so that means we have no holes. That's it. You are done. And this is Longo. I'm out. See you. Bye.